Today, we're going to write some Python code to do object labeling using a connected pixel algorithm, and also some code to do masking in order to reduce our image noise. First, you need to have OpenCV installed. So if you don't have that installed and you're watching this video through robogrok.com, there will be a link next to this video showing you how to install OpenCV. So we'll start just by writing some code to access our camera and show the picture on this screen. We have to first import NumPy, and then we'll also import CV2. Now we will access the camera and we'll call our camera connection cap. In parentheses here, we get to put a number telling OpenCV which camera we want to access. I'm going to start by putting 0 here because then it will access the very first camera that's in our list of cameras. You might have more than one camera connected to your computer, and so 0 is a good place to start. It will work if you have any cameras connected to the computer. Now let's create a loop, while 1. Inside this loop, we're first going to read an image from this camera 0, and the image that we read is going to be called frame. Now let's show the image that we just captured in a window. Now I need to have some condition to end this loop. So I'm going to make this loop end when you hit the escape key. So I'll do k equals wait key 5. This line is going to keep checking to see if you've pressed a key. And if you have pressed a key, then k will have some value. So we'll do if k is equal to 27. 27 is the value that k will have if you hit escape. Then inside this loop, we'll do break. Then outside the loop, which we'll indicate by unindenting, we'll do cv2.destroy all windows. Now let's test this. Run your code. Run module. You'll have to save. You should get a window pop up showing you the live image from one of your cameras. Now we want to access the camera from your kit. So let's set up a little test environment. Take your camera and attach it to the camera to board bracket and attach the bracket to the board so that the camera is looking down at the board. Now click on the live image that you have showing on your screen right now and hit escape. And the live camera image should disappear and your code will exit. Now we need to figure out which camera is the camera from your kit. Make sure the camera from your kit is plugged into your USB port, and you might need to close idle and then open it up again. Back in our code, we're going to increase this number by 1 and then try it again. Run the module, and we'll take a look at which camera this is. And you can hit escape to make your code exit and the window disappear. And you can keep increasing this number by 1 and running your code again until you find the camera that is the camera from your kit. Once you've figured out which camera is the camera from your kit, find the little bag in your kit that has different colored and shaped pieces and place several of the red objects in view at the same time. Make sure that the different red objects aren't touching, so your image should look something like this. Now, here's the problem that we're going to solve. In Robotics 1, we learned how to get an image where the red objects would show up bright and the background would show up dark. But we didn't have any way to deal with multiple objects in view at the same time. Our object labeling algorithm that we learned about today will allow us to find the location of each one of these red objects individually, even though they're all in view at the same time. So we're going to start by doing the same kind of thing we did in the past. We'll split the image into red, green, and blue components, and then find the red only part. So first, let's get the red, green, and blue components. To get the red component, we'll take all the rows, all the columns, but only the last third layer, which is layer number 2, since the first layer is layer number 0. In OpenCV, it doesn't go RGB as the order of the colors. It actually goes BGR, so that R is the last layer. So we can get the green layer like this. And we can get the blue layer like this. Now, this will not allow us to get rid of colors that are a combination of colors. For example, white will show up equally bright in the red, blue, and green image. So if we want to get the red only image, we could do that by taking the red image and subtracting the green and blue images. Before I do this subtraction, I'm going to change each of these matrices into a 16-bit integer. Then, after we've done this subtraction, it's possible that some of these pixels are less than 0 or greater than 255, but it's important for us, if we're representing this as an image, to limit the values to between 0 and 255. So I'm going to take this red only image, and I'll take all of the red only values that are less than 0 and set them equal to 0. Then I'll take this red only image and convert it to an unsigned 8-bit integer, because that's the data type of an image. Now, let's show our red only image in its own window so that we can check to see if everything's working okay. Let's do cv2.imshow red only. Red only. And then let's run this. So your RGB image should look something like this, and your red only image should look something like this. We have bright red objects on a dark background. Now we know how to find the center of brightness for this entire image. We can use the center of mass approach that we learned last semester. But what if I want to find the center location of each one of these objects individually? For that, we need to do image segmentation or run our object labeling algorithm. Let's add that to our code. Right now, the read-only image is a grayscale image. That means that each pixel has a value between 0 and 255. I would like to make this image into a binary image, or black and white, so that each pixel is either 0 or 1, or each pixel has either the value 0 or 255. So up here, instead of limiting things that are less than 0 to be 0 and things that are greater than 255 to be 255, let's pick a threshold. Let's say that that threshold is something like 127. So anything less than 127 will be set equal to 0. And anything greater than or equal to 127 will be set equal to 255. Let's try this again. Here I have the red objects in view like this. But my black and white image isn't very good. It looks like this. Since my red objects aren't showing up very well, that means my threshold is too high. Back here, I'm going to reduce this threshold from 127 to 50. And then try it again. My RGB image looks like this. And my black and white image looks like this. This is much better. The red objects are showing up white and the background is showing up as black. However, you'll notice that there's some noise in this image. There are some pixels in the background that should be black that are actually white. And there are some pixels in the objects themselves that should be white that are actually black. That's image noise, and we can use masking to fix that. We'll be doing that in a moment here. Now note that your threshold value here might be different than mine. Adjust this value until you get a nice image like this also, with the red objects showing up white and the background showing up mostly black. Once we do that, we can use a connected pixel algorithm. Let's add that to our code. We need to create a matrix that will hold the value of each object. I'm going to call that matrix labels. That will be equal to cv2.connected components. Then in parentheses, we put the matrix of the image that we want to apply connected components to. So I'll do red only. And then I get to say what is the connectivity level that we want to use. And for now, we're going to try a connectivity level of 4. Let's run this code and then we'll explore what the matrix labels looks like. So run the code, make sure you have some red objects in view, and make sure your black and white image looks something like this. Once it does, click on one of the images and hit escape to end the loop. Now, in your idle shell, type in labels and hit enter. It will show you what the labels matrix looks like, but only a little part of it. My labels matrix has a lot of zeros in it. In the labels matrix, each value tells you which object that pixel belongs to. For example, my labels matrix is telling me that each of these pixels belongs to object 0. Object 0 is usually the background. Let's see if we can figure out how many objects were detected by this algorithm. Type in np.amax labels and hit enter. My connected pixels algorithm has found a total of 8 objects because the maximum value in my labels matrix is 7 and one of the objects is object number 0. So I have a total of 8 different objects. That might be a little surprising because although I have a background, I only have 3 objects in view. I would like to have only gotten 4 objects. The reason I have more objects in my matrix than I have on my board is because of the image noise. Let's see if we can take a look individually at each of these objects and see what it is. Back in the code, I'm going to turn the labels array into a matrix, and I'll just call that matrix B for now. So B is np.matrix labels. Now I'll create a variable called obj1 for object 1. Object 1 will be equal to B every place that B equals 0. So in other words, object 1 will be a matrix that has a 1 in it only every place that B equals 0. Any place that B is not equal to 0, in other words, the label is not 0, then object 1 will have a value of 0. Now I need to turn object 1 into an unsigned 8-bit integer because that's the data type for images, and I want to view this as an image. Now I'd like to make object 1 any place it's greater than 0 equal to 255 so that those pixels will show up bright. Now we'll do cv2.imshow. We'll call this window first object, and what we want to display is object 1. I'm now going to copy this whole block of code and paste it a couple of times. I'll create a variable called object2. The way I look at object 2 is by changing the number here. I want object 2 to be true or high anytime the B, my labels matrix, is exactly equal to 1. Then I'll do the same thing here. Object 3. We'll get object 3 by looking at every place that the labels matrix is 2. The reason I'm showing so many different objects is because I want to get some of these objects to be not little bits of noise in the image, but actually one of my red objects that I'm looking for. Okay, let's try running this again. My RGB matrix looks like this, so I have 3 red objects in view. The first object image looks like this. As we expected, the first object is the background. Keep in mind that the white pixels are showing the location of the object. So the first object is pretty much just the background. Here's the second object. With the second object, I got one of the squares as the object. But here's my third object. My third object is just one little bit of noise. It's a single white pixel near the top of the image. So how could we fix this so that we don't get objects that are single pixels in the image? I only want to get objects that are actually the red objects in view. We could do this by cleaning up the noise before we use the object labeling algorithm. We clean up the noise by using masking. Go back up in your code to where we have the red only image. In OpenCV, we can create a mask like this. Remember that a mask is a small array of low values, like -1, 0, 1, 2, values like that. We apply the mask by multiplying every little piece of the image times the mask. Let's create a mask that is just ones and has 5 rows and 5 columns. Here we get to specify what data type this small array will be. I want it to be a uint8 because the mask is like a little piece of an image. Now I'm going to use a type of masking that's called opening. We access functions for different types of masking by using cv2.morphologyx. The first thing I put in the parentheses here is the image matrix that I want to be masked. So here, the thing that I want to be masked is the red only image. Next, I say what type of masking I want to do. Here, I want to do a type of masking called morphological opening. Lastly, I specify the mask that I want to apply. I called that mask. Now, let's show the object as it looks after the opening has been applied. Let's do cv2.imshow. We'll call this masked image. And the image matrix that has been masked we called opening. Let's run this code. Here's the red only image. You'll see how we have all kinds of little bits of noise, little white pixels in the black background that we would rather not be there because they're going to all show up as their own object. But when we look at the masked image, the noise has disappeared. If we would use the object labeling algorithm on our masked image, I bet it would work much better. Let's try that. Back in our code, instead of applying the labels to the red only image, let's apply the labels to the image opening. Now let's run the code. Click on your image and then hit escape to stop the code. Now let's type in np.amax labels. Here we only have 4 objects, objects 0, 1, 2, and 3. This is great. That's exactly the number of labels that I want. The label 0 should be the background, label 1 should be one of the objects, label 2 a second object, and label 3 the last object. Back in my code here, I see that I made a mistake. This object 1 should be object 4. When you have this working correctly, here's what you should see. Your RGB image should have 3 red objects in it. Then you should have an image called first object that shows the background in white. You should have an image called second object that shows only one of the 3 objects in view showing white. You should have an image called third object showing one of the other objects, and an image called fourth object showing your third object. Once you have this working, Take a screenshot showing all of these different images showing, and save your code. We're going to be using this same code to learn about AI for machine vision in the next couple of units.